Okay, so this is the range equation, and specifically what it does is if you have some launch velocity v, okay, and you're on some planet where there's gravity of g, and you launch it at some angle theta, okay, this thing in one swell foop is going to tell you how far it goes. I derived it in the previous video. Let's just use it right now. So let's suppose we take our rockets launch at 32.1 meters per second, and I launch it at 38 degrees. Okay? Then I'm just simply going to do this. 32.1 squared divided by 9.81 sine of 2 times 38. Okay? So on my calculator, let's do a quick check here, right? Turn it on. Let's go to the mode. I am in degrees, right? So that's good. Okay, and now I just simply type this in, right? 32.1 squared divided by 9.81 times sine of left parenthesis 2 times 38. Ta-da! And it's going to go 101.9 meters. Now, really, your rockets aren't going to go that far because we're neglecting air friction, right? They'll go about 80% that far. I'll just give you that. I'll throw that out there for you. Okay, 101.9 meters. Okay. Now, the second thing that we might want to do is we might want to solve that guy for theta, right? So let's solve that for theta. That's what we're doing here, right? So the range equals v squared over g sine of 2 theta. Okay, to solve that for theta, I'm going to go, the next step is g times the range, which gives us, somewhat surprisingly, Grange on the top, right? Okay, divided by v squared. That's the sine of 2 theta. And now to find what theta is, we're going to take the inverse sine of that, right? So inverse sine of g times the range over v squared. Okay, that's equal to 2 theta. So to get theta, of course, we got to divide that whole thing by 2. All right? Oh, there we go. So there's our solution, right? Okay. Ta-da. So let's, when we launched at 38 degrees, we got 101.9 meters. So let's answer 2 questions, okay? One question is, suppose the target were at 90 meters. What angle could we launch at, right? Well, let's find that. Okay, I'm just gonna plug that in, right? That's gonna look like this: sine minus 1 of 9.81 times 90 meters, right? This is meters per second squared, right? Divided by, and let's say our launch velocity is still 32.1, right? Right, and then that's divided by 2. That's going to be my angle. Okay. So let's type that into the calculator. Second sine 9.81 times 90 divided by 32.1 squared, right parenthesis, divided by 2. Okay, so it's saying I should launch at 29.48 degrees. Okay, now there's a really cool thing here. Okay, if 29.48 also works, there's another angle that will also work, and that's 90 minus 29.48. Okay, so let me just show you that, right? I'm going to store that guy in A, right? Okay, and then let's go 90 minus the answer and store that in B. Okay, so there are 2 angles there, right? I can launch at both of those angles, right? I can go 32.1 squared divided by 9.81. I'm using the range equation right there, right? Okay. Times sine of 2 times A, right? I get 90 meters, of course, because that's what we solve for, right? And then I can do the second thing, second entry, right? And I can launch at the other angle, the complement, right? Which is going to be 60.51, right? So I'm going to change that to B. And it's also 90, right? So if this angle works, right, theta works, also 90 minus theta works. There's theta, 90 minus theta, okay? One is going to be a low trajectory. The other will be a high trajectory, okay, for that, okay? Now, let's answer another question. That is, here we figured out what angle to hit 90 meters. Let's figure out one to hit 200 meters, which is way out here, right? Let's hit 200 meters. So that's going to be inverse sine of g times range, right? So 9.81 times 200 divided by 32.1 squared divided by 2. So let's try that, right? Second sine of 9.81 times 200 divided by 32.1 squared divided by 2, right? And we get like some weird thing here, okay? Well, what it's doing there is it's actually saying that we've actually got a domain error, okay? When you get a funky answer like that, you'll either get error or it'll like try to give you some imaginary number or some weird thing like that, okay? That's because it's too far away. This thing will never ever be able to shoot 200 meters. So whenever you get like a question mark, right, it's just too far. Okay? Okay? That's all you really need to know about the range equation.